Video lecture I will discuss about the phase velocity and group velocity. Uh, these two terms are basically associated with the matter waves, right? So de Broglie waves are associated with a moving particle. It means the velocity of the particle will be equal to the velocity of de Broglie waves. This is basic idea. So now the first question is that what is the phase velocity or wave velocity? Second, what is the group velocity? And then after, what is a wave packet or an envelope? Uh, it means that how to understand the basic concept of a wave packet और envelope क्या है और group velocity phase velocity या wave velocity से किस type से different है. And then after, what is the relationship between the group velocity and velocity of the particle? That is basically the motto of this lecture, which we have to prove. हम लोगों को ये प्रूव करना है कि जो वेव एसोसिएट है विद द पार्टिकल उसकी जो वेलोसिटी है दैट इज इक्वल टू द वेलोसिटी ऑफ द पार्टिकल. फॉर दैट ये इलेक्ट्रोमैग्नेटिक फील्ड का कंसेप्ट यूज किया है बेसिकली दैट इज रिलेटेड टू द फोटोन, right? And for a photon, energy of that photon is defined by E is equal to h nu, that can be written as h cross omega. This h nu in terms of the energy, and this is oscillator frequency in terms of the omega. So what is the relation between h nu and h cross omega? That is shown here. H cross is equal to h upon 2 pi. Omega is equal to 2 pi nu. So when you will put the value of h cross omega, it becomes h upon 2 pi into 2 pi nu. If 2 pi cancel out, so you have only this h and nu. So h cross omega is equal to h nu. Right. Second term is the momentum of the photon, that is equal to h cross k. Where p is a vector quantity, and here wave vector is also shown in terms of vector, that is equal to h upon lambda, and here vector k upon mode of this k, that is in terms of magnitude. So this term basically is equivalent to the unit vector k, that basically represent the direction of a wave, electromagnetic wave, right? And here p is the momentum of the particle, so that direction is parallel to this uh, parallel to the direction of the wave. So for a free particle, in case of a free particle, a plane wave can be written as in this form: psi rt is equal to a, this exponential term, I k dot r minus omega t. Right, this is a plane wave representation for a free particle. So using the above relation which I have discussed here, E is equal to h cross omega and P is equal to h cross k, I have to convert this equation, that is I mentioned here number 3, into the in terms of momentum and this energy by using these formulae. A is equal to h cross omega, so I can write here omega is equal to E upon h cross. P is equal to h cross k, so I can write here k is equal to P upon h cross. So I have to put the value of omega and k in this equation. This is k and this one is omega. So when I put the value of omega, that is equal to E upon h cross, so E upon h cross into t, and similarly here P upon h cross, this and this term as it is. So one can write equation number 3 in terms of energy and momentum by this way. So psi, that is a function of r and t, is equal to a exponential term of iota p dot r minus e t upon h cross. So this is our first step. Now following the de Broglie concept, right? The plane wave connected to the particle has a wavelength. Lambda is equal to h upon mv, right? So here the particle mass must be sufficiently small to generate a measurable wavelength. In earlier video I have shown that if I consider a 1 kilogram mass and velocity 10 meter per second, so the wavelength was approximately 10 raised power minus 35 meter. That was very small as compared to the dimension of the uh, ball or whatever the mass for that thing. So the point is, for the de Broglie, is that mass should be very small, sufficiently small, because we know de Broglie or dual nature uh, shows by those particles if the wavelength of the de Broglie wave or matter wave is comparable to the dimension of the matter, means size of the matter. So in case of electron you can see it, but all these things are discussed in earlier video. So the point is only here related to the phase velocity and group velocity. So mm, in the plane wave, this k dot r minus omega t is phase, so that is represented by alpha and it remain constant, right? So the wave plane wave basically propagates into the medium with velocity u, that is defined by dr upon dt, right? So alpha is phase of the plane wave and velocity of the wave is denoted by u. Now if I differentiate this alpha with respect to time, that will be equal to 0. So here are k is the propagation vector, that is constant basically. So k dot dr upon dt minus omega, when I differentiate this equation with respect to the time, is equal to 0. So k dot dr upon dt, as I mentioned here, that is the velocity of the wave minus omega is equal to 0. This can be simplified by this way: k dot u minus omega is equal to 0, where u is the phase velocity. So it can be written as vector k dot u is equal to omega. So now the velocity of the wave and the wave vector both are in same direction, so the angle between them will be equal to 0 degrees. So k dot u is equal to k u in terms of the magnitude. So one can write that u is equal to omega upon k, where u is the velocity of the wave and omega is the angular frequency, k is wave vector. So now if I put the value of omega, that is equal to 2 pi nu and k is equal to 2 pi by lambda, then this 2 pi nu is the value of omega and 2 pi upon lambda, this is the value of k. So after simplification I get here only nu into lambda, where nu is the frequency of the wave and lambda is the wavelength. This frequency can be defined in terms of energy, that is nu is equal to E upon h and lambda is equal to h upon mv, that is in terms of the de Broglie wavelength. Here further E is equal to mc square and this h. So now I am putting the value of nu and lambda in this particular equation, that is equal to u, and u is the phase velocity or wave velocity which is associated right now with a particle. So u is equal to mc square upon h into h upon mv. After simplification, the result is c square upon v. So what is the conclusion now? Here u is the phase velocity or wave velocity, right? That is basically associated with the particle. It appear this result is equal to c square upon v, where c is the speed of light and v is the velocity of the particle. So u, that is the velocity of the wave, that is greater than the speed of light. So right now you can see here this result, u is greater than c. So we know that no particle, no even a single particle can travel faster than the speed of light. So here phase velocity of matter waves is always larger than velocity of light, right? So there is a contradiction. It could not be possible that if any single particle can travel faster than the speed of light. So it means no single wave train is associated with a particle. So the particle is basically massive, so its velocity is smaller as compared to the velocity of matter waves. So in above discussion we have considered the plane wave as a matter waves associated with the particle, and the observation is this one, c square upon v. So phase velocity or wave velocity, right, of that plane wave is uh, larger as compared to the speed of light. So this result is not valid. So now there is something more, and something more means that we are not in this particular derivation are not able to define the velocity of the matter waves which are associated with the particle, right? So now a different concept came, that instead of a single wave, a large number of waves are associated with the particle, and those waves basically superimpose, and as a result they form a wave packet. The speed, the velocity of that wave packet basically is the group velocity, and that group velocity is equal to the velocity of the particle. So this is the idea. Now I have to focus on it and I have to drive that result. So group velocity, the group velocity is calculated using this formula. Vg is equal to d omega upon dk is equal to, I am multiplying this numerator and denominator by h cross. So this h cross omega and h cross k, right here, h cross omega, h cross k, and this can be written further as E is equal to h cross omega and P is equal to h cross k. So this Vg, that is the group velocity, is equal to dE upon dP, right? So the variation of energy dE of the particle moving under the influence of a force F along a path ds is defined by this way: dE is equal to F dot ds, where dE upon dP, this ratio basically is defining the group velocity. dE is equal to F dot ds, we have seen here, where force is the rate of change of momentum. So dE is equal to, if I put this value of force here, so dE is equal to dP upon dt dot ds. Now rearranging the term, so it can be written as dP dot ds upon dt is equal to dP dot v, because ds upon dt is what, that is the velocity. So this is velocity, and here in this result where dE is equal to dp dot v, scalar product between these two vectors, and the direction of velocity and momentum both are parallel, so they can be written in terms of the scalar. So here dE is equal to v dp. So again dE upon dp is equal to v. So dE upon dp is equal to v. V is the velocity of the particle, right? So here earlier we have defined it that Vg is equal to this Vg is equal to dE upon dp, and now from our result this dE upon dp is equal to v, that is the velocity of the particle. So by this way one can see that Vg is equal to v. So group velocity is equal to the velocity of the particle. Now the point is we have derived here a particular result where we have shown that group velocity is equal to the velocity of the particle. So how to understand basically this concept? This concept basically is explained on the basis of wave packet. So in this picture basically here you can see uh, this blue color line basically dotted line which basically cover this particular wave, right? So this is the result of large number of waves when they superimpose, and the amplitude of those waves are almost same, and there is variation into the k, or you can say that there is variation into the frequency, there is a small variation into the wavelength. So when they superimpose they basically develop this kind of pattern which seems inside. When you join all these nodes, so you get this kind of pattern which you see in dashed line, that is blue color. So this blue color basically is an envelope which cover these high frequency waves. So this envelope basically is known as wave packet, and this wave packet is speed of this wave packet. There are two things. One is the speed of this wave packet, and second is the speed of the wave basically, which is this one. This is the phase velocity, or you can say wave velocity, and second thing is the velocity of this wave packet, right? So here clearly mentioned that with red color line and this green color line. So this red color basically indicate to the envelope, and that is a wave packet, and the speed of that is determined by the Vg, which we have shown, and this is our particle moving with velocity v. So according to the de Broglie, the group velocity basically travel with the same speed as of the particle. And now the second point is that here you see maximum amplitude at the center, so it means the probability to find the particle is at the center. So this is the probability of the particle. It means a particle is at the center. There is very small probability at this end and at this end. So the chances, the probability to find the particle is at the center, and the speed of this particle is almost is equal to the speed of this wave packet. So this is the idea of wave packet and particle and dual nature of the particle. So here you can see easily this is the particle nature and this one is the wave nature. But what is the point? Point is that the wave packet only. Wave packet is the result of large number of waves. So instead of a single plane wave, there are a group of waves which basically superimpose, and because of that superimposition a resultant wave we find in this form, right? And this basically is covered by this envelope that is known as a wave packet. So speed of the wave packet is velocity of this wave packet into the medium is equal to the speed of the particle. Right, so this was the basic idea, and now you can see you get all these answers. That what is the phase velocity? Phase velocity is the velocity of a wave. Group velocity is the velocity of the wave packet, and wave packet is what? Wave packet is the result of superimposition of large number of waves which are associated with a materialistic particle. Right. What is the relationship between the uh, group velocity and velocity of particle? You have seen that earlier. Vg is equal to v. Vg is the group velocity and v is the velocity of the particle. So this was the idea related to the matter waves, about the phase velocity and the group velocity. Thanks for watching this video. If you have any question or any doubt, you can ask me.